Hello, our most valued student. My name is Confident and welcome to our revision session. And in this series of videos, I'm going to take you through electricity and magnetism and what you are expected in your exam if you're preparing for your grade 10 physical science. So this is going to assist you a lot. There's going to be not only one video, but I'll do a couple of videos that takes you through electricity as well as magnetism. And then with electricity, let's start with electrostatics here. It says sketch an atom and the charges which is of a neutral sodium. So the foundation I want to bring in here is whenever you're talking about electrostatics, you need to understand how charges are formed. For example, if I'm to sketch a neutral sodium, as it's saying here, a neutral sodium atom. So sodium, as you remember, has got 11 electrons, and then this is a sodium atom. It has got 11 electrons, it has got 11 protons, and it has got 12 neutrons. So the mass number of sodium is 23. So now if you are to draw or to sketch an atom of sodium, so I will have, let me have here a bigger nucleus, so like this. So you have got your first shell with 2 electrons, and then you've got your second shell with 8 electrons. All right, and then you've got your last shell with 1 electron, explaining why sodium is in group 1. So this is sodium, and then in the center, as we are saying here, that is your nucleus. And in this nucleus, that's where you find the protons. Now the protons are positive. The reason why sodium is neutral is that it has got 11 electrons which are negative, and it has 11 protons which are positive. So if you say negative 11 and positive 11, you get 0, which means there is no extra charge. So this is what we expect. So if I'm to also have it in kind of, let's say you have a sodium, this is just a demonstration. So it's more like you have a sodium, a ball of sodium like that, and then it has got like a positive, 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 positive. I have to make them 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are 11 positive protons, and at the same time I've got my 11 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this would be 11. There must be 11 altogether. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11. So there was an extra one like that. So this is what you are having. This is a neutral atom in a way. So now if it's not an atom, we can even call it a neutral, let's call it, it can be a neutral atom or a neutral sodium metal. Remember, now with the metal, it will be a group of atoms altogether. So this is what you like having when you're saying it's neutral. It means there is an equal number of positives as well as negatives. Now if they say here sketch a positively charged sodium ion and a negatively charged chloride ion and explain how these charges are obtained. It says positively charged objects are electron deficient and negatively charged objects have excess electrons. So what do they mean? So from here we said sodium had 11. If I'm to sketch now the new sodium which is positive, remember it had 1, 2, and then also we had the second shell with 1, 2, 3, 4, 5, 6, 7, 8. Now this is 10. Now because it is positively charged, we have got the last part here, which is the outside electron, and sodium will donate this outside electron, so it will lose it, right? And when it loses it, what is going to happen is you are going to remove this outer shell. And because of that, look at what changes now. We said in the center here we have protons in the nucleus. You have protons, and there are 11 protons. remember they are positive. Now because we lost an electron, now we no longer have 11 electrons, we have got 10 electrons which are what? Which are negative. So all of a sudden, if you look at the extra charge here, you have got a +1 charge on protons. There is a positive charge which is contributed by an extra proton. So if I'm to take this back into that sketch to say, suppose this is a ball, so I'll have positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we still have 11 protons, but look at the electrons now. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is this extra one here. You see, that is positive. So what we do, we usually say, you put a bracket and then you're saying this is positive. And then even here, when I'm to write this kind of a molecule like this, I mean of a metal, I will say this is sodium with a plus. I'll just put a plus. The plus is this extra plus here that is being that is responsible for the charge of sodium. It is the same thing with chloride. If I have let me do for the chloride ion. Chloride is the opposite. Remember, it's a non-metal, it gains electrons. So chloride, it's 17, so it's got 1, 2, and then there's another shell which is 3, 4, 5, 6, 7, 8, and 9, 10, and then there's another one which is 1, 2, 3, 4, 5, 6, and then 7. So this is chlorine, and then when we are saying it's going to gain an extra electron, because it has 7 on the outer shell, it is going to bring and gain an extra electron. It can be from sodium. But don't forget now, at the center, what do we have? We have here protons. Now the protons, how many protons do we have? We have also 17 protons. Remember, protons are positive. And then we had initially 17 electrons. That was a neutral one. But because it gained an extra electron, so we have got what? 18 electrons. So you see that now we have got an if you say 17 positive and 18 negative, we have got an overall charge of -1 extra electron. So if I'm to draw also a metal like this, so what I will have is, look at this, I'm going to have how many positive? 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is 17. Now look at the electrons I'm going to have. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these are 17 electrons, but remember it gained this extra one, so I will have an extra electron there. So what does it mean? It means the overall charge here will be same as saying this is chlorine, but it has got a negative. So what we do here, we usually put here and say this has got a negative charge because of the what? Of the extra negative there. Are you with me? So this is in general what I'm trying to bring in when we're talking about electrostatics. And if I can come back here, let me just do this. If I can come back here then and say I have in a way chlorine and sodium brought together. Remember we said sodium will be what? Sodium will be positive because it lost electrons and it has an extra proton. And then we said chlorine on the other hand, it looks bigger because it gains that proton, it will be negative. Now in electrostatics, these two, they attract each other. Understand? So unlike, that's where it comes back to the next part here, which says now short charges that attract and repel, like charges repel, and unlike charges attract. So what do they mean? They are saying if you have got a positive and you have got another positive, Now, because the positives are same charges, what they do is they will not attract each other, but they repel each other. You see, so they move away from each other when you try to bring them closer. Similarly, if I have a negative and a negative, you try to bring them together, these two are going to repel. Just in a way, remember I had sodium which was positive and sodium which was positive. If you try to bring them closer together, they repel each other. Just like in magnet, there is a north pole and a north pole. If you bring it together, it is going to repel. When it comes to also negative, we can picture like chlorine we did. If you bring those chloride that were negative, they will repel. But on the other hand, if I bring a positive and I bring a negative, then you'll see that these instead they attract. Are you with me now? So that's where you get now attraction. The force of attraction is in these. Are you with me? Why? It is because the positive and the negative, the other one is having more, the other one is deficient. So when they attract each other, they're trying to balance up each other. Okay, in terms of what? Remember, in terms of electrons. Now this is something I want to remind you to say NB. When whatever is moving is electrons are the ones moving, please, are the ones flowing. So don't always say the positive charges are flowing. It's only the electrons. So if you're having a positive charge, remember positive charges come from protons and negative charges come from electrons, right? So protons are always fixed. Remember, these are always fixed. They never move. But electrons are the ones that are flowing or moving. So whether you are gaining or you are losing, you are only gaining an electron or you are losing an electron. You will not gain a positive. Okay, so always remember that. Now let's move on to say charging of insulators. Says describe how objects or insulators can be charged by contact or rubbing, which is called triboelectric charging. So if you take a roller, for example, and you rub it against your clothes or against your hair, what you are doing is you are charging that roller, so it can gain electrons from your hair into the roller. It says, for example, if you rub Perspex rod with wool, the Perspex, it loses electrons to the wool. The Perspex rod becomes positively charged and the wool becomes what? Negatively charged. So what they are saying is explain why the pieces of paper are attracted to a roller, polystyrene, that has been rubbed against a cloth. So it's similar on both cases. So what happens is you take a ruler like this. This is a ruler. You rub it against it's a common experiment. You rub it against your hair. So what will happen is the ruler is going to gain electrons from your hair. Remember, I told you electrons are the ones that are moving. So the ruler is going to gain extra electrons like that. So it will have more like negative charges. And then if you have a paper, let's have a paper before. So this is our pieces of paper, a piece of paper. So before it had uniform charges. So it had, if I can have here, positive, 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 and then positive, positive, positive. So this is our ruler here, negative, 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 negative. See, it was what? This ruler was, this paper was neutral. So now we are going to bring this paper closer now to the ruler. Now the question is, what is going to happen now? Look what is going to happen to the paper. The moment you take this paper and you bring it closer without touching, you just bring it closer. Just want to make it the same size here. So the paper is here now. The question is, what is going to happen? Now look at this. Remember, we said positive and negative, what do? They attract. But negative and negative, what do? They repel. As well as positive and positive, what do? They repel. So this is what is going to happen in the same way. Because these are negative, they will now bring the ones that are opposite. You'll see positives coming closer now like this, because positive and negative, they attract. So we had 6 of them. So from this picture, so you see why positive, negative, they will use this attraction. So this negative will draw the positive, the negative from the ruler will draw the positive, so that there is attraction. But the other negatives, because they are pushed away or repelled by this other negative, they will be then on the far end. You'll see them this side like this. You see that? So what we have done is, this is in a way you have polarized this paper. So this is what causes the paper here in this center. There is attraction. See, that's why the paper gets attracted to the ruler. All right, so this is what is basically happening when we're saying a paper, when it brought closer to the ruler that has been charged, the pieces of paper are going to be attracted. Now look at this. Let's explain again this principle of polarization. It says explain how charged objects can attract uncharged insulators due to polarization of molecules inside insulators. Use example of Perspex and polystyrene. So now look at this. Remember in the beginning here, we said when you take Perspex and you wrap, it says, for example, if you wrap Perspex with a wool, it loses electrons. So if I'm wrapping Perspex, it loses electrons. But now say use the example of Perspex and polystyrene balls. Let's use to say Perspex is going to lose electrons. So you take so what you have, pretend I've got, this is my polystyrene balls. They are hanging here like this. See, they are hanging. But now I'm interested so that you can be clear in those charges. So let's make them big like this. So let's say this is an insulator, meaning there is no flow of charge on these strings, right? So these are insulator strings. So they are hanging. So this, we call it our polystyrene. We'll call it our polystyrene balls. Let's say when you remember, they are hanging, so they are neutral. The charges are neutral, so meaning positive, negative, positive, negative, positive, negative, positive, negative, whatever there, positive, negative, and negative. They are neutral. So even this one, 1, 2, 3, 4, negative, 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 negative. They are neutral. These are neutral. Now on the other end, I'm going to bring in my Perspex rod here, and my Perspex rod has been rubbed against a cloth, so we've charged it. So if you rub it against a cloth, we said it loses the electrons to the cloth. So when it loses, remember, when you lose electrons, what do you become? You are left with, you become positive. You become positively charged. Alright, because why? You lost some electrons that make you negative. So we have some charges here like positive on this polystyrene here. So when you start bringing this closer, you see now, when you start bringing this rod closer to these neutral poles, this is what you're going to start observing here. So let's bring it closer. Let me erase, because I want you to see the flow here. So the moment this, let me just do it here. I'll just do this. The moment this one, let's do this, take it away. The moment this guy comes closer, I didn't do what I want. I want to get everything here. Don't know why it doesn't want to give me all of it. Okay, let's try. There it is. The moment I bring this closer, then you're going to observe something now. So when it's closer, remember it was neutral, but it won't remain neutral anymore. Back to our charges. If you have a positive and you have a negative, what is going to happen? They're going to attract. And if you have a positive and a positive, they're going to what? They're going to repel. and if you have a negative and a negative, they're going to repel. So what you're going to see is you're going to see these positive charges running away from the other positive charges here. You see, they will start moving. They're not moving away, of course, but they'll move that direction. And then when the positive charges are moving that direction, even these, they will also feel the repulsion. They are also moving that direction. But what is going to happen to the negative? Because they are attracted, they want to move closer to the what? To the positive charge. So the negative, in fact, they are going to move like that. So at the end of the day, what type of a diagram are you going to have? You're going to have a diagram like this. This is still our balls. Remember, that's a ceiling. You have our balls like that, and you have our, I'm just making it bigger so that you can see. And then remember, we had our rod like this. I want the same thing here. It's very closer. So we are saying it is positive. So what you have, look, you'll have negatives here and you'll have positives on the other side. Even here, because there is positive and negative attract, then you'll have positives this side. So you see what you have done? What you have done, you have polarized these balls. Polarized them. Why? Polarization meaning the separation of charges. You have separated the charges in a way whereby the balls look as if they have got one side that is positive and another side that is negative. As you can see, positive and negative, what do? They attract. Even here, you have between the balls, you have positive and negative. They also what? Attract. So you see these balls in a way moving closer to each other. Are you with me? So after some time, look at this. If you allow now this to touch this polystyrene, if you allow it to touch here, it comes in contact with that so that the charges can now flow. So what will happen the moment it touches, even this ball here might now move and what? And touch there. See what is going to happen? So there's going to be a flow of charges now. Remember, we said the only thing that is flowing is what? It is electrons. Electrons are able to flow. So the electrons then are going to start jumping here, going inside here. See that? So this is the flow of electrons. So in the same way, electrons also are flowing like that. So you are seeing that electrons are now the one that are going into this particular Perspex. So what you're going to be left is, you're going to be left with the balls here that were initially they were neutral, but now what do you think will be the charges? Because they have been giving out electrons, they are now becoming positively charged, you see. And this one also, because it's been giving, it is left with a positive charge. Now unfortunately, because they are left with a positive charge, remember, same charges, positive and positive, they what? They repel. That's why you see that this one is now moving that direction, this one is moving that direction. There is a repulsion now. So what we have done is we have now charged these balls positively. Are you with me? So what we did do, that is the part when I say polarization. First you polarize them. If you allow the rod and the balls to come in contact, what you have done is charges are going to flow from, they always from charges flow. Let me write this. Charges flow. How do they flow? From negative to positive. Just remember why? Because the electrons are the ones that are moving. The protons never move. So it is the electrons that are either leaving or they are entering. Are you with me? So always remember that part. So with that, this is what we meant when we say this is what I wanted. I was now looking for my, this is what we mean when we say here, look at this. When we say here, explain how charged objects can attract uncharged insulators due to polarization using insulators. Use an example of Perspex. So uses of polarization, they're saying you use it is used to reduce pollution in factories by trapping dust particles in chimneys. So they use it as a way of trapping pollution, to reduce pollution. You see why? Because the dust particles are charged. So they find that maybe the dust particles are positive, and in the chimneys you line up, you charge the chimneys and make them negative. So when these dust particles are entering, they'll be attracted to these, you see. So, and then as well as spray painting of cars, that's the same thing. What is going to happen? They charge the car. For example, this is the car that they will be wanting, so maybe they make the car negatively charged around it. So the paint, when they are spraying, they charge the paint, the paint becomes positively charged. So when it moves, it gets attracted into the body of the car and giving you a uniform painting, unlike when you're going to use other ways of painting the car. So this gives a uniform finish. So that's what they use. Just remember that. So now when we come to that, is the end of this lesson here. The next part is I'm going to look at the law of conservation of electric charge with you, and then we're going to continue to look at the principle of charge quantization. So we'll look at examples here on the law of conservation of charge. We also look at the principle of quantization of charge, and then look at some of the examples in the exam that you're going to be expecting. So the next see, these are examples that I'm going to deal with now whenever you join me in the next lesson. So the next lesson is very crucial, because I now explain some of the questions that they bring in the exam, so that you can understand what is it that they bring in. So this is what you expect. So what I will encourage you is join me again in the next lesson, because you cannot afford to miss it. If you are not subscribed, I'll encourage you, become a part of the family. Join us, because there is a lot of videos that we bring in here that prepare you for your final exams. We've come to the end of our lesson. Thank you.